everyone. Let's talk about step back building. We are going to see what are these step back buildings. With step back buildings, we are also going to see what are step back setback buildings and where they are going to be used in the real world. Why we civil engineer needs to understand the concept of step back buildings and how we can model and analyze this particular thing in Etabs. We are going to see that thing in this particular video. So let's start. Okay, first let's see what are step back building. As you can see onto the right hand side diagram, this kind of buildings are the one which are going to be constructed on a slope, or you can say which are going to be constructed on hillside. So as you can see in the definition here, it refers to a structure that features a design where the successive floors of the building are set back further from the facade line of the floor below. You can see onto the bottom side, there is this floor, and onto the upper side there is another floor, and then onto the upper side there is another floor. Each floor is shifted upward because there is a slope onto the downward side. The slope can be of the ground line of you can say a hill, and you want to construct a building there. So in that particular case, what will happen? The floor, or you can say the successive floors, will be at a different you can say level. So that is going to be known as a step back building. Okay, this design creates, you can say, a stepped appearance. These buildings are going to be for like in step shape or a step size like that. Okay, now when we study step back building, there is another concept which is step back setback building. These buildings are going to be step back, but they are also going to be going to have a setback. Setback means the floor, or you can say the component, is going to have a bit of setback from the front facade line. You can see here, this is 1, 2, 3, 3-story, and then the other 3-story are set back to a 4-meter distance from the main facade line. Okay, so a setback building is going to be that one in which that the structure is going to be positioned at a certain distance away from the property line or street or another structure. So this is most common, you can say, a form of, you can say, a step back building. So generally, onto the hillside, when we are constructing something, for example, we are constructing a resort or a hotel, or it can be anything, we are going to use this concept, that is step back building. And in this video, I'm going to let you know, and I'm going to give you a simpler approach in how we can model a simple step back building in Etabs, and we can go with the designing and the analysis, all the things. Okay, there are a few things that we need to understand before starting the modeling. That is the slope of the hill. The slope of the hill can be determined by the field investigation, by the field surveying, and then after you can do the hit and trial, and you can make an plan of your building, and then after we can do the grid operations, and after that we can finalize the beam and the column sizes, and then we can model it in the Etabs. Okay, now the one thing that comes into our mind, that what is application, where we are going to use this kind of buildings. So first, we are going to use these kind of building in coastal cities or area with significant natural features. Okay, so this allows more occupants to enjoy the unobstructed view. As you can see into the right hand image, it's an image of an hotel, some step back building. So it gives an, you can say, broad area for the occupants to see an unobstructed view. Also, it improves the microclimates, that it can improve the microclimates by increasing the air circulation, because we are having an expanded area. Okay, sunlight penetration is going to be there. So these are kind of a win-win situation for both of these things. We are also going to use the place onto the hillside, and we can use it for the revenue generation. Like I told you earlier, that we can use it for resort and like the hotels and like that, all things. Okay, so how we are going to do it? I'm using a simple plan here. You can see onto the X direction, we are having 6 grid lines, and onto the Y also we are having 6 grid lines. Onto the Y, we are having 5-meter distance apart grid lines, and onto the X, we are having 6-meter grid lines. The slope is 28-degree slope. It is generally going to be 25 to 30, or it can be more than that, but the moment it is going to get increased, our engineering is going to be a bit complex. So we need to go likewise. The height of the floors are 3.2 meter each. So we are going to model this particular thing. This is the elevation, okay, or you can say a sectional view. This is the plan. The other things that we are going to use in this model are the model details. These are all the model details that we are going to use. I have taken these model details from a research paper. I'm going to put the link of this research paper in my description. You can also go there and study all of those research papers. This video is actually going to be for the students, the postgraduate students, the diploma students, the one which are studying the civil engineering or the construction engineering right now, or it is also going to be for the architectural students, because we need to understand these structures are not symmetrical structures. These are kind of an unsymmetrical structure. So we need to consider different approaches while modeling. Okay, so these are the things that we are going to do right now. Okay, so let's start first. First, we are going to start with the modeling. So let's open up the Etab. I have already opened the Etabs here. Okay, now what we can do, we are going to click on the new model here. So I'm going to click on a new model here, and we'll wait until the dialog box pop up. Now, into the model initialization tab, I'm going to use the use built-in setting. I'm right now using the Indian standards, that is the units is the metric SI, the section database is Indian, steel database IS 800 and IS 456 concrete design code. I'll press OK. Into the grid, we are having a right now uniform grid spacing. The number of grid lines in X direction are 6, as I told you earlier. Into the Y also, we are having 6 grid lines. In the X direction, every grid line is at 6 meter distance, and into the Y direction, every grid line is at 5 meter of distance. Okay. Number of stories, how much stories are there? If you go back here, we can see that there are 8 stories. This is the base. Like this is going to be the 1. It is going to be the base. The 1, 2, 3, 4, 5, 6, 7, and 8. So there are total 8 story. 8 story. Every story is 3.2 meter. So base is also, bottom story is also 3.2. I'm going to press OK. Okay, this is the basic grid line setup that we need to do in Etab. I'm using Etab Ultimate 18. You can use any of the Etab 18 or the higher version. Now, the grid has been finalized here. You can see this is 55555 and this is 666. Everything is okay. I'll go into the define, and first thing that we are going to define is the material property. I'm going to click add new material. I'm going to click Indian into the region. You can do with your respective region. Material, I'm right now defining concrete. Our concrete is M30. I'm going to press OK, OK, and press OK. Okay, sorry. Similarly, we need to define the steel also. So I'll go back again to the define material, add new material, India, concrete. Instead of concrete, I'm going to click rebar, and I'm taking a 550 grade steel bar. Its yield distance is going to be 550 Newton per mm square. Okay. Now we are going to define the section property. That is, I'm going to click section property, and I'm going to click frame section, because we need to define beam, column, and slab also. So first, define beam, add new property. There is a concrete rectangular by default selected. Go into this concrete rectangular. Now, according to our presentation, or you can say according to our data, I'm going to give it full screen. The beam size is 300 by 450 and the column is 450 by 450. Okay, so let's input this values. So I'm going to give it a name B underscore 350 cross 400, and I'm going to give M30 material that we defined earlier. So the depth is going to be, the size is 300 by 450. Okay, 300 by 450. So obviously the depth is going to be 450 and the width is going to be 300. I'm going to click reinforcement. This is a beam design. So we are going to design beam longitudinal by beam grade. Bars grade is going to be 550 that we defined earlier. Confinement bars also going to be 550. Cover let's 25 mm, 25 mm. Fix this. Okay, and press OK and press OK. So our beam has been defined. Again, click add new property, concrete rectangular. This time we are going to define column. Give it a name C underscore 450 cross 450. The name is optional. You can write any name, but it need to be understable. Okay. Select the grade. Size is going to be 450 by 450. Modify show rebar. This is a column. Select the grade of 550 for both the rebars, and everything is there. I'll press OK and I'll press OK. Okay, so the beam and column has been defined. I'll press OK. You can delete the other properties if they are not in use. Go into the section property again. Go into the slab section. There is a slab 1 already by default. Just name it slab 150. Make the grade to the M30, and the thickness of the slab that we are taking right now is 150 mm. Okay, and press OK and press OK. Okay, now everything has been done. The definition has already been done here. Let's click this plan view. And by clicking this upward button, we are going to get into the base plan. Let's go into the story 1 and start creating our column and beam. At first, what you have to do, create all of the beams and all of the columns at all of the stories, okay, in one go. Select all story from this bottom right corner, go into the quick draw column, select your column property, okay, there is the column property C, and drag all over the joints and create columns in one go. Similarly, click on beam and select this beam and cover all the beams. Okay, now escape out. So as you can see right now, what we are doing, we have generated or we have modeled column and beams at every plan and every story. Okay, but we don't want it like that. So for that, what we are going to do, we are going to delete the excessive ones. Okay, so first what you have to do, select this one story option onto the right hand story and go onto the story one. We are at story one right now. Okay, so you can see onto the story one, this is story one here. We don't have any beams or column downward side from this story one. Okay, so what you can do, you can select from this left to right hand side till this B line. Okay, so it will select all the beams and all the columns till that particular position, and it is selecting only up to that particular story because we have selected one story at the bottom. Now press delete. Now what it's going to do, it is going to delete all of this particular things up to story one. Similarly, go a story up, that is a story two. Now again select from left to right, but this time stop at the third grid line. Okay, we are going to stop at that particular position because we need step up. So we are going like particular that thing. So we are going to delete up to third grid line. Okay, similarly, go once up again, select again, and this time only up to this particular position, delete. Sorry, again go up, and this time only this particular story, delete. Okay, now if we go up, we can't go onto the further right hand side, so this is it. Okay, now go into the 3D view, click this rotate button and try to see if the structure is looking okay or not. If you are unable to see the structure in a dark, you can say color, you can always use this option to extrude the view, and by extruding view you can see that the structure has been modeled correctly or not. Right now we can see it is modeling perfect. You can also see this elevation of the number one grid line. You can go onto the elevation, you can select this one and you can press OK. This is going to give you the elevation. Okay, so everything is looking good. Now we need to give the fixed support condition to the column side. Okay, so go on to the story one again. I'm going to go into the story one again, select like this. Okay, you can select all of those things like that particular thing. Okay, or you can do one thing, that you can go onto the bottom, first fix all of these joints, select all of this joint, assign joint, restrain, and give them a fixed restrain. Apply. Okay, so it is fixed. Now let's go up just onto the story one, select these are already, you can say, fixed. Okay, so we need to select these supports. These supports are not been visible in this view because columns are starting from this particular position. So you just have to select all this invisible C grid line supports. Okay, go on to assign, joint, restrain, fix, apply, and okay. Similarly, go once up. This time select these invisible D line joints, assign, joints, restrain, fix, apply, okay, and do it one by one. Go up, select this E1, assign, joint, restrain, apply, okay. Similarly, go again last time up, select this F joints, assign, joints, restrain, fix, and apply, and okay. Okay, now go on to the view and refresh window. This is going to refresh the window for us. This is going to clear out some of the things which are not right now visible. You can also go on to the refresh views for refreshing the particular views in which you are right now. So you can see the supports has been defined on all to the columns. So we are 50% done here. Okay, the modeling has been done already. So you can see onto the 3D view, if I go here, it is going to look something like this. Okay, you can always click the rotation button and you can rotate and check all of these things. You can right click and select this button, set grid visibility, to have more clear view of this particular step back building. Now, so everything has been done. Okay, so the modeling has been done. We need now the loading and the analysis. You can see here this is a spatial moment resisting frame. This is an office building. It is in seismic zone 5th. The soil type is medium right now here. The other things that we have is the loading. Onto the terrace, that is onto the top, we are having a dead load of 3.3, and onto the terrace we are having a live load of that is 1.5. But other than that, we are having 1.2 of dead load and 4 kilonewton of 4 kilonewton per meter square of the fluid load. So let's do what? First, go on to our structure and we are going to make the slabs for the loading. Okay. So I'm going to click on this, that is the plan view. Okay. And we need to make the slabs first. So first, let's turn off this extrude view just to have an fast processing. Go to the story one. Okay. And I'm going to click on this quick draw floor model. I'm going to select my property, that is slab 150 here, and click one by one. Why I'm saying click one by one? Just to ensure that everything is going to be okay. Okay. Just make sure that one story option has been selected here. Click here. Okay. Similarly, click here and click one by one. There is no hurry in it, because if you are going to choose the all story option, it is going to replicate all of the things in a one go. Okay. So this is done. Let's go on to the top building, and now we can cover these two portions. Similarly, click up, cover these all portions. Similarly, click up, cover these all portions. Similarly, up, these all option. Now go up. This is story number 5. We also have story number 6, story number 7 also, and at last story number 8. Done. Escape out of the command. Now you can come onto the 3D view and extrude them to have a better view. Okay. So you can see our structure is going to look like. You can also rotate by pressing the shift and the middle mouse button. So it is going to look something like this. So everything is okay. Now let's try to apply loading. First of all, we are going to save it. So I'm going to save it with step 03 name. Okay. Now let's assign loadings here. How we can assign the loadings? Let's go into the first we need to select the slabs. So go into the select, and we are going to select by the property. We are going to click property and then slab section. We need to select all the slabs with the property, that is slab 150. And we are having slabs only of this property, that is slab 150 only. So we're going to select it. It is going to select all the slabs from all the stories. But right now I want to apply the loads on the slab other than the terrace slabs. So we need to deselect the topmost slabs here. So how we can do that particular thing? Go into select, go and click deselect, then go on to stories here. And we need this 8 story as an deselection. So select 8 story and click deselect. So what it is going to do, it is going to deselect the upper stories and all the bottom stories has been selected. Now go on to assign, go on to shell loads and uniform load. We are applying shell loads and it is a uniform, so it's a dead load. So dead load is how much? It is around, you can see 1.2 floor finishes. So 1.2 is going to be there. I'm going to hit apply. Now the moment I'm going to hit apply, the selection is going to get lost. You again need to go to the select, and there is an option get previous selection. So select this one, all the previous selection, the last selection is going to be there. Click live load, and here we need to put the live load. The live load is 4. I'm going to 4. I'm going to hit apply and press OK. So everything has been done. Now the only thing that is remaining is the top floor. I'm going to activate this 3D view. Going to get select, property, slab selection. I'm again going to select all the slab, but this time I only need the topmost slab. So go on to select, deselect stories and select story 7 and press shift on your keyboard and select the last one. This is going to select all the stories that we want to deselect. That is from story 1 to story 7, or you can say from base to 7. So click deselect. What it is going to do, it is going to select only the topmost. You can just select. So let us assign shell loads uniform, and we need to first give it a dead load. The dead load is a bit more than the bottom one because it is having you can say a waterproofing substance. So it is going to be 3.3 kilonewton per meter square. I'm going to hit apply. Again, I'm going to select, get previous selection, and this time I'm going to select, give it a live load. And live load is simple. It is of 1.5. So it is of 1.5. I'm going to hit apply and hit apply. Okay. You can activate the 3D view. You can default click on the 3D. So you can see these are the loads 1.5 onto the top. That is, these are the live load, and all the bottom stories are at 4. You can check the loads from this particular option, display shade load assign. Right now the DAD is selected. I hit apply, and you can see 3.3 is on the top and 1.2 is at the bottom. Okay. Sorry. So you can see it here. That is, the dead loads are 3.3 onto the top and 1.2 at the bottom. Similarly, onto the live, hit apply. You can check those also. Now there is other thing also, that we are going to construct the walls also. So onto the beams, there is a 5.5 kilonewton per meter load of the walls is there. So we need to select all the beams here. So activate the 3D view, go into the select property, frame section. We are selecting all the beam section right now here. Select all the beams are going to get selected. Go into assign, beams are the frame, go into frame loads, distributed load. We are right now applying a dead load of the wall, that is of 5.5 kilonewton per meter. If you don't know how the wall loads are going to be calculated, please watch a video of structural load calculation. Okay, it's already available on my YouTube channel. You can watch there, and you can see and you can get the concept how this 5.5 is going to get calculated. Okay, so this is the load of the walls on the beams. So we're going to hit apply and press OK. So you can see it has been done. Control plus S save, or you can save it from this disk icon. Okay, so our modeling has been 90% done. The modeling has been done, the loading has been done. The other thing is that we need to apply the earthquake load. We are right now doing a linear static analysis here to make our video simple, a bit simple. Okay, so we can go on to define. Here we have a load patterns. Onto the load pattern, let's define earthquake in X direction. Just give it a name of your choice. I am giving it EQX. Select seismic here. Select your design code here. I am selecting IS 1893. I'm going to click add new load. Similarly, into the Y direction, EQY, seismic is there. I'm going to click add. Select EQX, go on to modify. We are going to modify because this is only in X direction. So let's uncheck all the other things. This is going to apply from base to the story top. The response reduction factor is going to be 5 because it is an SMRF building. The zone factor according to the fifth zone is 0.36. The soil is medium, so it is going to be second type. The importance factor is right now 1, and I'm going to press OK. Same I'm going to do for the Y also. Let's uncheck all except the Y direction. All the other things are as it is, same. I'll press OK. I'll press OK. Again, go to define, go to load combinations, generate some of the load combinations from here. That is concrete frame. I'm going to press OK. Press OK. These are the load combination. I'm going to press save. Now, at this particular point of time, everything has been done. Okay, the modeling has been done, the loading has been done, the linear static analysis parameters has been done. Now you can go ahead and you can start analyzing it. Before analyzing, I have always told you that you need to check model for any of you can say the tolerances. Okay, so I'm going to select all of this. I'm going to press OK. So the message is clear. Model has been checked. No warning messages are generated. So our modeling has been done. You can click on this show undeformed shape to see the clear diagram of your, you can say, structure. Okay. Now let's go into analyze and click run analysis. It is going to analyze our structure and it is going to give us the deflection in X and Y direction. It is also going to give us the shear force and bending moment. We can also check the reactions at the bottom. Okay. So as you can see here, the analysis has been done. If you want to check any of these things, you can usually do it from all of these options available here. I'm right now going to jump directly onto the designing mode. You can check out the bending moment and shear from all of these options that I have already taught you in my Etabs series. You can go and watch it there. I'm going to go into the design, concrete frame design. I'm going to start the design. Let's start design. And it is going to design all the columns and beam for us. And if anything is going to get failed, it is going to let us know that the thing is getting failed or not. Now you can see here the designing has been done. You can go onto the design, concrete frame design, and there is an option that is verify all member passed. I'm going to click on here. That is all concrete frame passed the design check. So our structure is getting passed with these, all the, you can say, the beam column dimensions, the site conditions, and all of our analysis. So in this video, I have told you, or I have taught you a very basic way of, you can say, modeling a step back building. And now I'm going to give you an assignment of modeling a step back setback building. You need to set back every story by, you can say, 6 meters back, and you need to model it, and you need to design it. If you can do it, please let me know. And if you are getting any problem, please write it down in the comments. This file, Etabs file, has been provided by me for you in the description below. You can go there and you can take this Etabs file for your educational purpose, and you can use them from that below link. It has already been modeled and designed there, so you can get the file from there. So thanks for supporting again. If you have any question, any query, please do ask me in the comments. Thank you. Bye bye.